ULA is using a Delta IV Heavy rocket to launch the NROL-71 mission. This is the 38th Delta IV launch since the inaugural flight in 2002 and the 11th flight of the Heavy configuration. Produced in Decatur, Alabama, the Delta IV Heavy, the nation's proven heavy lift launcher, is comprised of 3 common booster cores, each powered by Aerojet Rocketdyne RS-68A engines, and a Delta cryogenic second stage powered by an Aerojet Rocketdyne RL-10B2 engine. The NROL-71 payload is protected during ascent by a 5-meter diameter payload fairing. Let's have a look at a few of the events that took place in preparation for launch. On October 26th, the spacecraft, encapsulated inside the payload fairing, was transported to the Mobile Service Tower, or MST, at Space Launch Complex 6 and mated to the Delta IV Heavy rocket. Earlier this week, the Mobile Assembly Shelter, or MAS, was moved to its launch position. The MAS protects the Delta IV rocket from the wind and fog so common to its location here on California's Pacific coast. Final launch preparations at Space Launch Complex 6 begin with rollback of the Mobile Service Tower, or MST. Using 40 hydraulic cylinders at pressures nearing 3,500 psi, the MST was raised 8 inches and rolled back, revealing the Delta IV Heavy. At 100 feet by 100 feet by 300 feet, the MST is as tall as a football field is long, as wide as the length of a basketball court, and weighs in at about 10 million pounds. Using a carriage transporter system traveling at about a quarter mile per hour, it takes about 25 minutes to roll the MST to its launch position 300 feet east of the rocket. The Delta IV Heavy stands 232 feet tall, or about 23 stories, and weighs about 1.6 million pounds fully fueled. The 3 Delta IV RS-68A main engines produce more than 2 million pounds of thrust. Approximately 6 minutes later, at stage separation, it weighs just 7% of what it did at liftoff.
Minus 21 minutes.
The NRO is a joint organization engaged in the research and development, acquisition, launch, and operation of innovative overhead reconnaissance systems necessary to meet the needs of the intelligence community and the Department of Defense.
The NRO is recognized for its innovative intelligence collection systems that are used to develop highly accurate military targeting data, support international peacekeeping and humanitarian relief operations, and to assess the impact of natural disasters. The art for today's mission depicts an eagle as a symbol of both freedom and the nation, providing a fitting mascot to represent NRO's support to our nation's warfighter. The initials JLC on the foreground dog tag are in honor of Colonel Joshua L. Chamberlain, a Union commander who was awarded the Medal of Honor for his heroism at the Battle of Gettysburg on July 2, 1863, when he held the Union Army's southern flank at Little Round Top against a repeated assault from Confederate forces. Colonel Chamberlain's heroism, leadership, and commitment to service before self exemplifies the ethos of the American warfighter who the NRO is committed to serving each and every day. The art also includes the NRO mission number 71, along with the Delta IV Heavy in Vandenberg Air Force Base to indicate both the launch vehicle and location. The motto, "Serving those who serve," rounds out the logo and represents the NRO's commitment to delivering the mission on time to the warfighter and intelligence community.
T-minus 9 minutes.
We anticipate entering the planned 15-minute hold momentarily. The team is still working to an 8:15 p.m. Pacific launch time. If you've ever seen a Delta IV Heavy lift off, you may have noticed it seems to emerge from a cloud of fire. Recently, I had the opportunity to sit down with propulsion engineer Chris Coleman, who explained how it works.
So, Chris, we know that the Delta IV Heavy is the nation's proven heavy lifter, but when it lifts off, it seems like it's coming out of a cloud of fire.
Yeah, so Delta IV is hydrogen, so hydrogen being very light gas, it wants to float up, large buoyancy, and then you add fire to it, sort of like hot air balloons. First thing we do is we inject hydrogen down in the flame duct, light it off, and before the engines come up to power and evacuate the duct, you end up getting a hydrogen fireball that comes up the side of the rocket.
So we changed the Delta IV ignition sequence to include a staggered start. Was that anything to do with trying to prevent some of that fire?
So it is to help minimize the amount of environment on the rocket, essentially bring it from a 3-stick rocket to a single medium stick rocket. And in doing so, we reduce the char on the side of the rocket. What you'll see with the staggered start is that the one rocket will start early and you'll see the fire come up the one side of that one rocket. And then the other two start up 2 seconds later, and the fireball isn't nearly as high visually.
So what I'm hearing is that this fireball and the charring on the side of the vehicle, really it's all expected.
Yes, the rocket is designed in such a way that we apply cork on the bottom end of the rocket, which is very resilient, and then the foam along the cryogenic tanks. They're all designed in such a way that with the thickness and the charring, that it protects the rocket itself from the environment.
So I know with the Delta IV Heavy, we tend to run a little fuel rich. Does that tend to contribute anything to the fireball?
Not necessarily. So a hydrogen rocket, you'll tend to, due to the way the math works out, you want to go a little bit fuel rich. What we're seeing on the rocket is mostly hydrogen that we've introduced first in order to chill the hardware prior to starting up and spinning up the pumps. And that flame is really an open air flame, not necessarily one that's mixed with liquid oxygen.
So was the staggered start ultimately effective in doing what you wanted it to?
Yeah, it was quite effective. We actually ended up getting pretty much as we predicted, an environment pretty similar to a medium rocket or a single booster rocket. The results you can see actually on an NROL-65 mission where we had the char layer essentially go down.
Well, Chris, I really appreciate you taking some time to talk to me today. It's really interesting to hear more about what causes the big fireball at liftoff as well as what staggered start has to do with it. So thanks again for coming out to talk with me.
Happy to help.
One drain valve cycle test.
Roger.
Tonight's mission is ULA's 9th and last for 2018. The year ends as it began, with a mission for the NRO. It also included the first Mars mission from the West Coast and the bittersweet last flight of the venerable Delta II. Let's take a look back.
Liftoff of the United Launch Alliance Delta IV rocket, preparing the NROL-71 mission.
Liftoff of the Atlas V rocket.
Liftoff of the Atlas V. NOAA's GOES.
Liftoff of the United Launch Alliance Atlas V rocket with Space 11.
Liftoff of the Atlas V and NASA's InSight.
Liftoff of the mighty Delta IV Heavy rocket with NASA's Parker Solar Probe.
Liftoff of the final Delta II.
And liftoff of the AEHF-4 mission carried by United Launch Alliance Atlas V rocket.
T-minus 4 minutes in holding. This is a 10-minute built-in hold.
LC switch to not ready position. ALC, please set the countdown clock for a new T0 of 041500 Zulu.
Roger. LC countdown clock has been set for a new T0 of 14:15 Zulu. Or 04:15 Zulu.
Roger.
L minus 14 minutes.
So as you just heard, we have entered a planned hold, and we are still on target for an 8:15 p.m. Pacific launch time.
HazGas LC.
Go ahead, LC.
Establish HazGas scan pattern 140.
Roger.
NRO launch mission managers, who are junior U.S. Air Force officers working at the NRO, are responsible for putting multi-billion-dollar satellites into the right orbit at the right time in support of the warfighter. It's a unique job in the Air Force with a tremendous amount of responsibility that develops Air Force officers and future NRO leaders. Here's a behind-the-scenes look.
ALC.
Go.
AC.
AC is go.
RC.
Clear to proceed.
Launch director.
The launch vehicle is ready to launch.
The National Reconnaissance Office is focused on overhead intelligence, really focused on our satellite systems that are able to provide persistent overhead intelligence, especially focused on areas of denied access. A mission manager is responsible for mission integration, and what that means is we have a whole team of folks that are responsible for making sure that the launch vehicle is secure, is safe, is well built, and it goes through the proper factory processes. We also have a whole team that does that on the satellite vehicle side. My job as a mission manager is to bring those two together and really focus on the payload to launch vehicle interface. I was the mission manager for NROL-55. It's one of those unique jobs that you kind of get hand-selected for just based off of job performance. It's a job that's very unique in the Air Force that you, at a very junior level, are able to be responsible for a multi-billion-dollar satellite. When I started as a mission manager, I was 27 years old. It's been a great experience for me at such a young age to have that opportunity to really excel and to learn by doing, not by watching others do.
So being a mission manager for the NRO is a huge benefit to future jobs as a senior officer, having to interact with senior leaders, understanding technical information and being able to communicate that to anybody else who needs to know those details. So I'm responsible for the spacecraft as it processes through the launch base, gets rolled out to the pad and stacked onto the launch vehicle, and then the actual operation to launch the rocket and put the satellite on orbit. The people who make the decisions, the mission director, the program director, they have a lot of responsibility to make sure that this payload gets put on orbit safely. But the fact is that I'm the guy who knows exactly what's going on with the mission on a day-to-day basis, and I'm the one who's explaining all those details to the people that are high up in the organization.
We have main engine ignition, 2, 1, and liftoff.
So I've launched about 12 missions so far. Each launch is different, each launch is hard, and you feel great after it gets off the ground and gets up into orbit.
I was a mission manager for one launch back in 2009 to 2011. The most favorite job I had in the Air Force so far. Taught me so much about how small we are individually, but how powerful we are as a team. The mission manager job, I think, is really designed to be a junior level captain, early major, because it gives you an opportunity to learn so much about a system. You learn from the requirements phase to the operations phase. You are involved in every aspect of a mission, and it's crucial in the development of Air Force officers and future leaders in the NRO. The day of launch was very tense. I remember those last few seconds very vividly. We were all watching the clock, and as soon as those trophies ignite and that plume went up around the rocket, and you just pray that thing gets off the ground, and it did. And we had a moment where we could run outside and check it out, and it was fantastic.
Launching is a means to an end. Being able to actually put a satellite in orbit is why we're here. So the fact that my launch vehicle was able to put our satellite in the right orbit at the right time was what mattered. And so once we got confirmation of that, it was the moment I had been waiting for, which is to really be able to celebrate our accomplishment.
My job is the best job in the National Reconnaissance Office. It's been hard and challenging, and that's really what makes the job fun. It's working together with the community to put this payload on orbit for the warfighter.
LC flight control, launch on time verified.
Roger. LC switch to ready position. All steps are complete prior to the status check.
L minus 8 minutes.
We remain in the planned built-in hold. In a few moments, launch conductor Dylan Rice will poll the team for the final go to pick up the countdown. 31 engineers and managers will be polled for system status and readiness to proceed with the launch. This is the final status check before launch for all Delta vehicle systems, ground systems, the spacecraft, and the U.S. Air Force Western Range. The readiness poll includes hydraulics, pad water deluge system, electrical systems, pneumatics, propulsion systems, flight control, and propellants. Let's listen in as launch conductor Dylan Rice performs the final polling of the team.
Status check to proceed with terminal count, first stage systems, propulsion.
Go.
Hydraulics.
Go.
Locks.
Go.
LH2.
Go.
Second stage systems, locks.
Go.
LH2.
Go.
Electrical systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
COM.
Go.
TC cubed.
Go.
Operations support.
Go.
Pneumatics.
Go.
Umbilicals.
Go.
HASGAS.
Go.
ECS.
Go.
Redline monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
AC is go.
Range coordinator.
Clear to proceed.
Launch director.
Launch vehicles ready to launch.
Mission director.
You have permission to launch.
Proceeding with the count. ALC verify T0 is set for 0415 Zulu.
Verified.
L minus 6 minutes.
MEQ establish swing arm lock pins pulled.
Active.
Polling is complete and the launch team has given the go for launch. The countdown will resume approximately 2 minutes from now. At T-minus 4 minutes and counting, we will enter the terminal count and begin securing the second stage liquid oxygen tank. At T-minus 3 minutes and 32 seconds, CBC liquid hydrogen and liquid oxygen tank securing is started, including closing the propellant fill and drain valves. Also at T-minus 3 minutes and 32 seconds, vehicle transfer from ground facility power to its own internal battery power will be complete. At T-minus 3 minutes, the vehicle ordnance system will be armed, and the CBC liquid oxygen and liquid hydrogen propellant tanks are verified to be at flight pressure and flight level. At 2 minutes prior to liftoff, the team will verify that the hydraulic system is pressurized and confirm CBC, DCSS, and FTS battery voltages. At T-minus 1 minute and 20 seconds, the team will begin securing the second stage liquid hydrogen tank. At T-minus 60 seconds, Western Range readiness is verified. At T-minus 50 seconds, the DCSS liquid hydrogen tank is secured at flight level. At T-minus 15 seconds, the ROFIs are ignited at the base of the vehicle to burn off excess hydrogen. At T-minus 7 seconds, the starboard CBC engine is ignited. At T-minus 5 seconds, the port and center CBC engines are ignited. Liftoff will occur at T0. This is Delta Mission Control at T-minus 4 minutes and holding. We anticipate releasing the hold in just a few moments.
T-minus 4 minutes and counting. 3:59. 3:55.
Second stage lock, secure at flight level.
Ground pyros enabled.
The countdown clock has resumed and we are go for launch at 8:15 p.m. Pacific.
307. $249.
FTS internal.
CBC locks, flight pressure and flight level.
Two minutes. 159.
Hydraulic pressure at 4,000.
155.
Launch sequencer started.
CBC LH2 at flight pressure and flight level.
140.
FCS launch enabled.
137.
T-minus 90 seconds. The launch vehicle, payload, ground systems, and western range are go for launch.
120.
OCU's armed. FCS count started.
T-minus 1 minute.
Start box, go.
Rock, report range status.
This is the Rock. The range is green.
50.
Second stage, LH2 secure at flight level.
30.
Status check.
Go Delta.
Go NROL-71.
23. $15.
Brophy ignition.
T-minus 10, 9, 8, 7, 6, 5. We have ignition. 4, 3. Hold.
Page 181.
A hold has been declared. We are standing by for more information.
Yeah. MECO confirmed.
Flight control aborted at approximately T-minus 7 seconds. To the TISR abort.
Roger. And flight controller, are you ready to reset the clock to T4 and holding?
I am ready.
Roger. ALC, reset the countdown clock to T-minus 4 minutes and holding.
Roger. Countdown clock has been reset to T-minus 4 and holding.
Roger.
FCS is in pre-flight mode.
Roger. Prop 1, verify safe RS-68 shutdown and purge configuration as follows. We're active. DST-1. BSS-4 to switch BSS-1 and BSS-2, force to channel 1.
In work.
MEQ, swing arm lock pins install.
In work.
LC can report pad as normal. ALC, establish engine cooling water off.
Water off. LC fuel 1.
Go fuel 1.
At step 60, fuel 1 is nominal.
Roger.
Or correction, that's step 80.
Understood.
LC PLE on 1.
Go PLE.
Yeah, we're still in our second stage lockup. We'd like to go ahead and vent the second stage LOX tank at this time.
Proceed.
LC per step 80, substep Bravo, fuel 2 is nominal.
Roger.
LC MEQ.
Go MEQ.
Lock pins are installed.
Roger.
LC, it's USO. We did scan, and pad is normal.
Roger. USO pad status normal.
LC, this
Prop
is
1's nominal.
pad is normal.
Roger. OSM pad is normal. And Prop 1, you're calling in nominal as well?
Yes, sir.
Roger.
LC LOX 2.
Go LOX 2.
LOX 2, nominal.
Roger.
LC LOX 1.
Go LOX 1.
LOX 1 nominal.
Roger. PNE at step 90, establish PSN2.
Roger. And that's verified.
HYE, secure hydraulics.
Roger.
A hold was called approximately T-minus 7 seconds due to a problem detected by the terminal countdown sequencer rack. The clock has been reset to T-minus 4 minutes while the team evaluates the next step.
Reset.
PNE, verify nose cone purge on and set heater to 164 degrees.
Verified.
FISPO, LC, net 1.
This is FISPO.
Report ready to safe vehicle ordnance.
Ready to safe vehicle ordnance.
Verify FISPO concurrence to safe FTS.
FISPO concurs.
FTS, LC.
Go ahead.
Command FTS safe and external.
In work.
LC, FTS,
Go.
net 1.
Go, FTS.
FTS safe and external.
Roger. OSM, place SRM ignition switch to disable position.
SRM ignition disabled.
MEQ, report swing arm system secured.
Secured.
ALC on TC emergency panel, remote cameras normal.
Normal.
PNE, configure helium supplies.
In work.
Flight controls ready to proceed to detanking.
Roger. All personnel proceed to Operation 80, scrub detank. LD, LC, net 1.
LDN 1.
Okay, at this time, recommending we proceed into detanking operations.
Please proceed, LC.
Flight control, terminate option 910 and reset 910 flags.
Roger. Option 910 terminated and flags reset.
Roger. Redline monitor, LC.
Go ahead.
Stop redline monitor.
Roger. Red line monitor stopped.
Roger. ALC, adjust clock to T plus 5 minutes and start plus count.
Roger.
Has gas, LC.
Go ahead, LC.
Proceed with CBC loading has gas scan pattern 305.
Roger.
This is Delta Mission Control. It has been confirmed that we will not continue with Delta IV NROL-71 launch activities tonight, and a new launch date has not been identified. For the most up-to-date information, please visit ulalaunch.com, follow us at ULA Launch, or call 1-877-ULA-4321. This concludes tonight's coverage. I'm Tyler Strickland. Thank you for joining us.